So now we'll discuss about the gravity on the sun surface. Gravity on the sun surface. Gravity on the sun surface, very important. So gravity on the sun surface, right? So gravity on the sun surface. To understand the gravity on the sun surface, first you should know what is the gravity or what is gravitational force of attraction. So here always one object will attract the another object, and that if suppose there are two objects, it is one object, it is the another object, small object, it is object 1, it is object 2, and it is m1 mass of object 1, it is m2 mass of object 2. So m1 attracts m2 with a force that we call gravitational force, and the gravitational force will be equal to product of masses of this m1 and m2 or two objects divided by the square of distance between them. If suppose here the distance is d, if distance is d, that listen, if the distance is d between these two objects, right, this is the distance d, so distance is d, and your object m1 it attracts m2 with a force is equal to product of two masses divided by square of the distance between them. So already you have studied in your school days this formula, right? So the larger objects will consist more gravity and the smaller object consists lesser gravity, and as sun is very large, sun should consist more gravity, and earth is smaller than the sun, the earth should consist lesser gravity, and moon is further smaller than the earth. That's why moon consists minimum gravity. Moon consists minimum gravity, earth consists medium gravity, and sun consists maximum gravity, right? So now we'll discuss about we should discuss what is the value of gravity on the earth surface, moon surface, and sun surface. First one, gravity on the earth surface. Let's listen. Gravity on the earth surface. Gravity on the earth surface. So gravity on the earth surface, if you take this is the earth, let's listen, earth, so earth consists gravity, this is equator, 0 degree equator, and this is poles, north pole and south pole, right? The value of gravity will be more at poles, right? At poles G value will be 9.81 meter per second square, and here also at south poles also G value, gravity value 9.81 meter per second square, right? So this is Z earth, this is also Z earth, Z earth meaning just what meant. So this is G poles, near poles the gravity value will be, this is G poles, this also G pole, near poles the gravity is 9.81 meter per second square, and gravity at equator, Z equator, it's 9.79 meter per second square. So from this equation you can understand which part of earth having more gravity. Answer is poles having more gravity, and which part of the earth having lesser gravity. So answer is equator having lesser gravity and poles having more gravity, right? And if you take the average value of gravity, listen, average value of gravity on earth surface, average value of gravity on earth surface. So here 9.81 plus 9.79 divided by 2, so you will get 9.8 meter per second square. meter per second square, right? So this is the Z earth. Gravity on the earth, it is 9.8. This is very important, put double star here. So if you get the question, what is the value of Z on the earth surface? So answer is 9.8 meter per second square. What is the value of G at poles? 9.81 meter per second square. What is the value of G at equator? 9.79 meter per second square. What is the average value of gravity on the earth surface? So answer 9.8 meter per second square, right? Very important point. So this is gravity on the earth surface. Now the gravity on the sun surface, just listen, next point is gravity on the sun's surface is 28 times the gravity value on the earth surface. So here gravity on the sun surface is 28 times, very important point, sun surface, it is 28 times the gravity value on the earth surface. So that is G sun is 28 times G earth. So whenever you write in the equation, you have to write, whenever you write in the sentence, you have to write in the equation also. So this is a sentence. Gravity on the sun surface is 28 times the gravity on the gravity value on the earth surface. So your gravity value on the sun surface is equal to 28 times the gravity value on the earth surface, and we know that. So here 28 into 9.8 meter per second square, and it would be 274 meter per second square, right? Gravity value on the sun, so it is 274 meter per second square, very important. So if you get the question, what is the gravity value on the sun surface, it is 28 times more than the gravity value on the earth surface. Why? What is the reason? Because sun is very large than earth. Object those are having bigger size, those are having more size, they will have more gravity, and object those are having lesser size or smaller size, they will have lesser gravity, right? So G sun will be 274 meter per second square. So now another very interesting point. So what is the gravity value on the moon surface? This question came many times in UPSC exam, in KS exam, any CAPF exam, CDS exam, NDA exam, SSC exam, railway exam. In most of the exams, this question came, right? Gravity on the sun surface. Just listen. So next point, gravity value on the moon surface. Gravity value on the moon surface. So gravity value on the moon surface is 1/6 of gravity value on the earth surface. Gravity value on the earth surface, right? So gravity value on the moon surface is 1/6 of gravity value on the earth surface, right? So earth surface, for example, Z moon is equal to 1/6 into Z earth. So here 1/6 into Z earth is 9.8 meter per second square. So it is 1.62 meter per second square, right? So here Z moon so Z moon is 1.62 meter per second square, very important. So this is the equations. And UPSC, but in KPSC exam they can ask direct question, what is the value of Z on the moon surface, they can ask direct question. And what is the value of Z on sun surface? They can ask direct question. But in UPSC, they will not ask such factual things, but they will ask, arrange the following in decreasing order as per their Z value or as per their gravity value. If you get such questions, so you should know the value of Z on the moon surface, earth surface, and even the sun surface, right? So you are arranging the following. So first one is gravity on the earth surface is 9.8. Gravity value on the sun surface is 274 meter per second square, and gravity value on the moon surface is 1.62 meter per second square. So here, if you get the question, arrange the in decreasing order. So G sun is greater than Z earth. Z earth is greater than Z moon. Z moon. So gravity on the sun surface, it is 274 meter per second square, which is greater than 9.8 meter per second square, which is greater than 1.62 meter per second square, right? So this is in decreasing order. Okay. So in decreasing order. So decreasing order. In decreasing order, G sun is greater than G earth is greater than G moon. And this is important for your PRELIMS exam, IAS PRELIMS exam. Very important. They'll ask such questions. Arrange the following objects in decreasing order. As per decreasing value of gravity. They can ask the question, arrange the following object in decreasing order as per their density. They can ask the question, arrange the following object in decreasing order as per their even density or gravity or even mass also. So this is about the gravity, right? So now we'll discuss another very important topic. So that is structure of the sun. Next heading, structure. Structure of the sun. So a structure of the sun, very important. Structure of the sun. So structure meaning, just listen, when you get the question about structure, so here you have to explain about different layers, right? Different layers. So here are different layers. They are asking structure of the sun, nothing but they are asking to explain the different layers of the sun. Just listen here. So here, just listen, don't write. Suppose this is the inner core, the inner layer, then it is radiative zone, convective zone, right? And then we are having outer layers like photosphere, chromosphere, and corona, right? So like that we are having total 6 layers. Just listen. So sun, that if you get the question, how many layers are present in sun, or sun consists how many layers, then answer is 6. So sun consists total 6 layers. 6 layers, and the 6 layers are broadly classified into 3 inner layers and 3 outer layers. 3 outer layers, 3 inner layers and 3 outer layers. Just listen. So these 3 are the inner layers and these 3 are outer layers. These 3 are outer layers, right? So your inner layer 1, 2, 3, 4, 5, 6. So total there are 6 layers, 3 inner layers, 3 outer layers. So 3 inner layers are core, and second one radiative zone. Third one convective zone. And third 3 outer layers are, one is photosphere, and fifth one chromosphere, and sixth one corona. They are very important. These are the six layers of the sun. But in exam, there is no need to draw such diagrams. You have to draw very simple diagram you have to draw, right? And because in UPSC, so you'll get only 3 hours time. In 3 hours time, you have to write answer for 20 questions. And to write answers for 20 questions, you have to reduce the space, you have to reduce the time also. And rather than drawing such big diagrams, you have to draw the small diagrams. Right, I will draw one diagram here which is very important for your exam, right? Very important, right? So first you take this diagram and then later I will explain about these points. First you take this diagram, a very important one. So this is okay. So this is first one, it is core and it is radiative zone, it is convective zone, and then we are having here photosphere, it is chromosphere, and outer side is corona, right? So first one is, this is the first layer, it is second layer, third layer. First layer is known as core, second layer radiative zone, third layer convective zone, convective zone, right? And next one, it is photosphere, and second one chromosphere, and third layer is corona, right? Third layer is corona. It consists of burning gases, right? So photosphere, chromosphere, corona, and core, radiative zone, and convective zone. The first three, they are known as inner layers. These are inner layers, and next three, they are outer layers. Inner layers, and next three are outer layers. Right? This is magnetic field. Strong magnetic field. Again here also strong magnetic field. Right? And here weak magnetic field. And the radiation starts from this region. This radiation goes outside, right? And some of the radiation it comes back. Some of the radiation comes back, that we call solar flares, and the radiation that goes towards earth is known as solar winds. It is known as solar winds, and this is solar flares. And this area we call sunspot. This is also sunspot, right? And then we are having here earth. Earth, Earth, right? And then we are having here troposphere, stratosphere, troposphere, stratosphere, mesosphere, ionosphere, exosphere. Here also troposphere, stratosphere, mesosphere, ionosphere, exosphere, right? And even there is very important magnetic field also, so which we call, which is the part of, it is the part of exosphere, right? So exosphere. Okay, this is the magnetosphere, which is part of exosphere. Magnetosphere. And this is solar wind. This solar wind, it travels towards the north and towards the south also. And this solar wind, it forms different colored light in ionosphere. Red light, so it forms red light, and then green light. Here also green, then blue light, and then it forms yellow colored light, and then it forms pink colored light. Okay, it's very important. It's a repeatedly asked questions in competitive exams. Listen. So here in ionosphere, you'll find these colorful lights, and these colorful lights is known as aurora borealis and aurora australis. So this is aurora borealis, and this is aurora australis, right? Aurora borealis and aurora australis, these are the colorful lights. Very important, the colorful lights forms in both the hemispheres, right? So this is a colorful light forms in both the hemispheres, that we call auroras, aurora borealis and aurora australis, right? Aurora borealis and aurora australis. Okay, listen. So aurora borealis and aurora australis, and they forms in ionosphere. If you get the question, in which layer of the Earth's atmosphere auroras will form, then answer aurora borealis and aurora australis. Aurora borealis are also known as, listen. So here aurora borealis, they are also known as northern lights. Are also known as northern lights, and aurora australis are also known as southern lights. Very important. So aurora borealis and aurora australis, right? And solar winds travels with speed 900 kilometers per second. 900 kilometers per second. Solar winds, and it known as solar flares, or these are also known as solar mass ejection, also known as solar mass ejection. So solar mass ejection or solar flares and solar winds and aurora borealis, northern lights, aurora australis. So these are very important components of our sun structure, right? So here listen, and sunspots, and these warm areas we call plages. Warm areas are known as plages. So plages meaning warm areas. Warm areas we call plages, and cold areas we call sunspots, right? One more interesting point, just listen. So very important point here. So because of strong magnetic field, so the sunlight, suppose this is the sunlight radiation, and this radiation will reflect back, and it circulates. And here also the radiation, right, it reflects and completes the circulation. It circulates. So that circulating radiation we call the convectional cell, right? We call convective cell. Very important. It is the convective cell. It is also known as convective cell. Very important. So these are the repeatedly asked questions, right? Like what is auroras, right? And what are the solar winds? So what is solar winds? What is auroras, right? It's repeatedly asked question, right? So aurora borealis and aurora australis, very important. And now like recently it's very much in the news also, aurora borealis and aurora australis. So recently you might have seen in the newspaper as well, right? So the auroras are increasing in the polar region, because auroras will visible only in the polar region. We can't see from the equator, because from equator, so the distance is very high, right? You might be knowing the troposphere is very thin at poles, and troposphere is very, you can say, it having more thickness at the equator. So at equator, so here the thickness of troposphere is almost 18 kilometers, and thickness of troposphere at poles it is approximately 8 kilometers. So thickness is less at poles and thickness is more at the equator. Why? What is the reason? The main reason is, so the insolation meaning incoming solar radiation. So from the sun the sunlight will come, and when the sunlight comes from the sun, they comes with more energy, that we call incoming solar radiation, and they comes with a short wavelength, right? Because wavelength is always inversely proportional. Remember, if suppose this is the wave, right? In this wave, this one we call the crust, and this is trough. This is crust and this is trough. So this elevated land or raised part of the wave we call crust, and this depression we call trough. This is also trough, right? This is the trough, and this also we call the crust. And the distance between any two successive crust is known as wavelength. This one we call wavelength, right? And the distance between two successive trough is also known as wavelength. And wavelength always it is measured in meter. And please remember, if energy is more, and there will be more cycles, we call frequency nothing but number of cycles per second, we call the frequency, right? And if suppose in this wave, so this is one cycle, so one complete crust and one complete trough we call one cycle. This is one cycle, and this is second cycle, and this is third cycle, right? And this is three and a half, or you can say it's a fourth cycle. So these four cycles, number of cycles per second we call frequency, and this is the wavelength. These are the wavelengths, right? So it's meaning with increase in energy, frequency also increases, but wavelength decreases. So here the wavelength decreases with increase in energy. Energy and wavelength are inversely proportional, and energy and frequency are directly proportional. With increase in energy, so frequency also increases. You might, the practical thing, for example, so during stitching machine, when we increase the pedaling, the number of cycles increase by the needle. So if suppose this is the cloth, the number of cycles increases if you increase the pedaling, and when you reduce the force, then what happens? that you will find the such kind of structure, right? So because the wavelength will be more with lesser energy, and when you apply more energy, so you'll find stitching like this. So that time the wavelength will be very less. So wavelength and energy will be inversely proportional, right? So please remember, when the light comes from the sun, it is a short wave and more energetic. And when the light reflects back, listen, suppose this is the sun, and when the light reflects back, that we call OTR. OTR nothing but outgoing terrestrial radiation. Suppose this is the sun and this is the earth surface. So the radiation comes in the form of short wave, and the radiation will reflect back in the terms of long wave. So this is short wave, and this is long wave. So that we call OTR, outgoing terrestrial radiation. And equatorial region receives more insolation. Equatorial region receives more insolation. Remember, so equatorial region, it receives more insolation, and that's why air becomes more warm, and the warm air will rise up to maximum height, and that's why at equator the thickness of the troposphere is more at the equator, and thickness of the troposphere is less at the poles, and that's why even the ionosphere also very close to the poles, and ionosphere is very high, it is at high altitude, or the height is more at the equator, and that's why we can't see auroras from the equator, but we can see aurora from the polar region. Very important topic. So auroras, it is very much in the news also, right? And so we'll stop here, and in the tomorrow's class again we'll discuss in detail what is auroras, right? In which part of the earth we can see more auroras, and why these colored light will form, why only red light, why only green light, why only yellow colored light. So we'll discuss in detail, because it's a very wonderful mechanism, and this topic is very much in the news also. I'm expecting one question in this upcoming exams, so that we'll discuss in the tomorrow's class, right? Thank you so much, take care, bye bye.